All right, boys and girls, we're going to spend a second day on this section 1.1 here because I know the word problems especially are a little tricky and difficult to especially understand exactly what the textbook is wanting to get from you. So we're going to go over this again just so you understand kind of what I expect and how to put the answers in the book so you can get the right answers when it comes to tests, etc., etc. So again, there's a 4-step approach recommended for problem solving. Understand the problem, make a plan, solve the problem, and then look back and see if your answer makes sense. Now you need to understand that a couple of these things, getting the answer, great. I don't just want answers, I want equations. I want you to show me that you know what's going on. So we went through this one on last week. It says Usain Bolt won the 200-meter dash for the time of 19.32 seconds. Write an equation to find his average speed to the nearest hundredth of meter per second. We went through this one last week, but we'll run through it again just to kind of set the pace here. So first off, understand the problem. You know the winning time and the distance of the race. You are asked to find the average speed of the nearest hundredth meter per second. So you make a plan. Distance formula, we touched on this last week. D equals RT, that's an equation that's going to pop up frequently. You should know that one. All right? Solve the problem. Write the distance formula. D equals R times T. Substitute what you know. 200 is D for the distance, 19.32 for T for time, and then we solve the equation. It's the multiplication equation. We divide to solve the equation. We come up with 10.35 for R. That is 10.35 meters per second for Usain Bolt. Okay? Does that answer make sense? So if we look back, round Bolt's average speed to 10. At this speed, it would take 200 meters, 10 meters per second would take about 20 seconds. He did 19.32. The answer makes sense. You don't have to check exact numbers, just rough estimates when you're checking your answer. Like I said, we did that last week. Let's approach it from another problem. So suppose Bolt ran 400 meters at the same average speed that he ran the 200 meters. So now we're going to take that same idea and we are going to reapply it. So we're keeping the rate the same. We're bumping the distance to 400. The rate, what was that rate again? 10.35. So now, and the question is, how long would it take him to run 400 meters at this? So how long is asking you a time question. So now we're going to take both sides of the equation and we're going to divide by 10.35. And it's going to come up with T for our answer. Oh, wrong button. Is the answer? Oh, there. So that gives us 38.65 seconds. So again, take the answer from the previous problem and reapply it to a new situation. Same formula, but now we've changed the distance to 400 meters. So we plug in 400. It says same average speed, so we use the same average speed, rate is speed, and it asks you how long would it take? So we're trying to find T. How long would it take? Use the formula, divide to find the new time, 38.65 seconds. So again, some strategies you can use. Verbal models, draw diagrams. Those are real helpful sometimes depending on the problem. Diagrams are really helpful to get you a visualization of what's going on. Patterns, work backward. It's great if we want answers. Hard to write equations from working backward. Guess and check, we really don't want to do that one, but it is a strategy. Sketch graphs and number lines, tables, lists, and just break the problem into parts. These are a bunch of different strategies you can use to help you solve the problem. So let's take another one. This one's a little tough to read. It says on January 22, 1943, temperature in Spearfish, South Dakota fell from 54 degrees at 9 a.m. to negative 4 degrees at 9:27 a.m. Okay, how many degrees did the temperature fall? Now hopefully in about, 10, 15 seconds, most of you could tell me the temperature fell 58 degrees. Okay, it went from 54 to negative 4, you know it fell 58 degrees. But here again, I'm not looking so much for an answer, I'm looking for an equation and a setup because you're going to be asked to do the equations when you have your assignments. So let's go through our process. Understand the problem. You know the temperature before, you know the temperature after. You're asked to find out how many degrees it fell. A verbal model. Before, fell, change. Okay, pretty simple. So the temperature at 9:27 is the temperature at 9 a.m. minus how far it fell. There's just an idea. This right here, just to get your thoughts in order in a structure like an equation, will help you because now, well, I know this, this is what I'm looking for. Just by filling that out and thinking in this structure, it helps me write an equation. Equation, okay? Note, when we say equation, I did not write t equals -4 minus 54, okay? Your equations have the variable and a number on the same side. Don't write, if I ask you for an equation, don't write this something, x equals something, t equals something. That's not an equation, it doesn't count. The variable and some numbers have to be on the same side of the equal sign for it to count as an equation. So here's our equation. We can solve, subtract 54, -58 is -t, divide -1. So there's our temperature. It fell 58 degrees. Again, the answer is not so much the important thing here. I want you to be able to set up an equation. All right? Does that make sense? Look back. Yeah, if I start at 54, I go back 58, I'm in -4. It makes sense. All right, make sure you're using this and writing equations when it asks you to write equations, not just answers. That's not going to be good enough, okay? All right, that's all I want to talk about today. Just kind of go over some of these word problems again. You got some more of the same on your assignment, and let me know how this setup's working for you. If you have problems looking off the smartboard. Take care.